We're often told this story that science pretty much went dark for 1,000 years after the Greeks. But today, we're going to dig into a totally different story, the incredible and often overlooked astronomical revolution that happened in the medieval Islamic world. So let's start with a big question. What if that whole story is wrong? We all learn about the ancient Greeks, and then we hear about the European Renaissance. But what about the huge gap in between? Was it really just some long, quiet, dark age for scientific discovery? Well, it turns out that while Europe was going through its Middle Ages, a whole other part of the world was in the middle of a vibrant golden age, an era of discovery that would literally, fundamentally reshape our understanding of the cosmos. Yeah, we kind of have this simple picture in our heads, right? It's like a relay race. The Greeks run their leg, hand the baton straight to the Renaissance, and then they hand it to us. But that story, it completely skips a critical handoff, a really transformative part of the race that took place over 1,000 years across the Islamic world, from Spain all the way to Persia. So, what was the spark? What lit the fuse for this incredible explosion in astronomy? Well, it turns out it wasn't just pure curiosity. It was something deeply practical, something woven into the very fabric of daily life and faith. Let's start with this concept, the Qibla. If you're a Muslim, you need to pray towards Mecca. Now, think about that. Finding that one specific direction from anywhere on a round Earth, well, that's a seriously complex problem in spherical trigonometry. You can't just guess. You need advanced math, and you need to know exactly where the stars are. And it wasn't just the Qibla. I mean, think about it. You need to calculate the 5 daily prayer times, which shift every single day of the year. You have to figure out the exact start of holy months based on the moon. You need accurate calendars, and of course, you need to navigate the massive trade routes. All of these things, absolutely essential activities, demanded a precise and reliable science of the heavens. This wasn't some abstract hobby, it was a necessity. And this right here, this is the perfect symbol of that connection, the Astrolabe. This thing was like the smartphone of its day. No joke. It was a sophisticated little analog computer that could tell time, figure out prayer times, chart the stars, find the Qibla, you name it. It's the physical embodiment of science in the service of society. But here's where the story gets really, really interesting. These astronomers, they weren't just using the old Greek knowledge they had translated. Oh no. They were actively challenging it, questioning it, and improving it. They weren't just librarians. They were critics and innovators. And that's the key takeaway here. This was never just about preserving old books. It was about correction. It was about innovation. They looked at the ancient Greek models, saw things that just didn't add up, and they were determined to fix them. They wanted a system that wasn't just good at predicting things, but one that was physically true. Take their critique of Ptolemy, for instance. For centuries, his model of the universe was the gold standard. But astronomers at places like the Margaha Observatory in Persia, they had a huge problem with this one mathematical trick he used, called the equant. Sure, it kind of worked on paper for predicting where planets would be, but it violated the beautiful core idea of uniform circular motion. It just felt wrong. It didn't seem physically real. And get this, we're talking about the 11th century here, and the great polymath Al-Biruni was openly debating whether the Earth rotated on its own axis. That's 600 years before Copernicus. He ultimately decided it was a question for physics, for natural philosophy, not just a math problem. That just shows you how deeply they were thinking about the actual physical nature of our universe. So if you're going to throw out Ptolemy's equant, you need something better, right? Well, they invented it. They came up with brilliant new mathematics. This is the Tusi couple, this elegant geometric tool that allowed them to create the motions they needed, but without Ptolemy's physically messy fudge factor. It was a huge mathematical breakthrough. Now, all of this incredible innovation wasn't happening in some isolated bubble. Which brings us to our next point, and honestly, it's pretty startling. These breakthroughs didn't just stay in Persia or Damascus. They built a bridge across centuries and cultures that led directly to the European Renaissance. So let's just look at the timeline for a second. In the late 1300s, an astronomer in Damascus named Ibn al-Shatir creates these powerful new models for the planets, using tools like that Tusi couple we just saw. Then, fast forward over 100 years, and a certain Nicolaus Copernicus starts sharing his own revolutionary ideas. And here is the jaw-dropping connection. Historians of science have discovered that the mathematical models Copernicus used for the moon and for Mercury are not just similar, They are identical to the ones Ibn al-Shotir had already developed. The geometry is exactly the same, a one-to-one match. So you have to ask, right? Coincidence or connection? Was this just a case of two brilliant minds centuries apart, independently coming up with the exact same complex solution? Or was Copernicus aware of and building upon the incredible work of his predecessors from the Islamic world? It completely reframes how we think about the scientific revolution. But the story doesn't stop with a bridge from east to west. It's actually bigger than that. We're talking about a truly global network of scientific exchange, one that also reached far to the east, connecting the great minds of Persia and China. Yeah, this network was flowing in all directions. At that same Raga observatory, the one that was challenging Ptolemy, there were also Chinese astronomers working alongside their Persian colleagues. The Persian astronomer Jamal ad-Din actually traveled to the court of Kublai Khan, bringing with him a whole set of advanced instruments and helping to set up an Islamic astronomical bureau right there in Beijing. So a diagram like this, it wasn't just a pretty picture. It was a piece of shared knowledge. This vision of the cosmos, with all its intricate spheres and zodiac signs, was like a common scientific language. It was understood and debated by scholars across thousands of miles, linking these vast, diverse cultures in one common quest for knowledge. So, when you really step back and look at the whole picture, you see that the history of science isn't that simple relay race we imagined. It's so much richer, more complex. It's a global human conversation, a dialogue stretching across centuries, where ideas are shared, challenged, and made better by people all over the world. And that really leaves us with a final thought, doesn't it? Learning about this forgotten golden age of astronomy completely redraws our map of scientific history. It just makes you wonder, what other crucial chapters of the human story, what other amazing histories are still out there, just waiting for us to rediscover them?